Hello and welcome everybody. Today we're going to learn about the Euclidean algorithm, which is used to get the greatest common divisor of a and b. Now we have to have a and b such that a and b belong to a set of integers. A times b does not equal 0. That means a does not equal 0 and b does not equal 0. And the last condition is that b is not a divisor of a. Okay, let's get started. So the thing is, we need to get the GCD of a and b, and you could do that by, let's just have a equals q1b plus r1. Now this is, you could get this quotient and this remainder somehow, some way you could find it such that you get this equation. And now you actually take this b and take this r1. So the next step, so this would be step 1, this would be step 2. B equals q2 r1 plus r2. Again, you would find an equation such that b equals some multiple, some linear multiple of r1 plus an r2, a remainder. And again, do it as this, which r1 equals q3 r2 plus r3. Now this goes on and on until, until you need to. You get r n minus 1 equals qn plus 1 Rn plus 0. So you do it until you get an Rn, which is a non-zero, I'm sorry, the last non-zero remainder. And this works because of something, of a proof that I did last time. I'm gonna just put it over here somewhere. I haven't decided yet, either here or here, but yeah, and this is done because by proof that the GCD of a and b, let's say you have a equals qb plus r. GCD of a and b equals the GCD of b and r. So, in this case, we have r1 and q1. So GCD of a and b equals GCD of b and r1. And then from the next step, you get GCD of b and r1 equals GCD of R1 and R2, and so on and so forth, all the way to you get the Rn over here. I'm just going to do a quick example. This is all going to make way more sense with an example. So, example, let's say A equals 100, and just to kind of stir things up, B equals negative 35, just to make it a little difficult. Now, it is... now, A is 100. What would happen if A was negative 35, B was 100? You could do that, but it's just easier if, the absolute value of A is the higher one. So we have this, and the step 1 would be to create an equation such that 100 equals something times 35 plus a remainder. Now, if you do negative 2 times negative 35, 70 plus 30. So this equation is correct. Then we get step 2. We get now negative 35. Like I said, this comes over here, and this over here equals something times 30 plus a remainder. So let's have negative 2 times 30, or negative 60, plus 25. You always want to make the remainder a positive number. And now we go step 3. 25. My apologies. 30 equals something times 25 plus a remainder. Now this is simple, 1 times 25 plus 5. And this actually stops at step 4 because 25 equals 5 times 5 plus 0. And this is the last non-zero remainder. So this 5 is actually the GCD of 100 and negative 35. And this one, was a simple one because, the factors of 35, let's say it's positive, is 7 and 5. Now, 7 obviously doesn't go in 100, but 5 does. So this was a more simple one, but Euclidean algorithm is very helpful in finding the greatest common denominator of, larger numbers. Very simple, a couple of steps is all that's required. Okay, I hope all that made sense. If you do have any questions, feel free to leave it in the comment section below. Like and subscribe are always appreciated. I try to push out a new video of what I think is pretty cool every day. That's why my name of the channel, name of my channel is just a guy who likes math, because I think all this is cool. Anyway, I hope you have a good rest of your day. Again, any questions, feel free to let me know. And until next time, peace out.